This conference will now be recorded.
Okay, I see the recording has started, so let's begin. Just to introduce myself, I'm just into IT industry from last around 19 years now, and worked with varieties of technologies, including Java, Advanced Java, PHP, Oracle, Salesforce, and so just to keep it brief, let's come to the topic which we're going to discuss today. Um, for the purpose of this particular session, we are talking about Java's multi-threading concept, and which falls into the category of advanced Java. So before initiating the concept, I was just discussing there are a couple of terms which we use in IT industry like multiprocessing, we have multitasking, we have multi-threading. So just a brief idea about so that we don't get confused in amongst these. So let's talk about multiprocessing. Now, multiprocessing happens when we have multiple CPUs on our machine or multiple processors are doing many activities in parallel. So normally we can see such things where our heavyweight operations like satellites are moving and all the military operations are going on, or medical imaging systems in which we have mainframe and supercomputers where we have a couple of CPUs and each CPU is doing one particular job at one particular time. That is multiprocessing. Then let's talk about multitasking. So multitasking is you have commonly seen your operating systems, whether you are working on Linux or Windows or Mac, where you can see you can open Word, you can play music, you can browse on your internet browser. So you can open multiple tasks in parallel, which are getting executed simultaneously. Now, if we talk about behind the scenes, this is controlled by the operating system. It is not happening that multiple tasks are getting executed simultaneously. It is just that CPU is very high speed and your operating system is giving turn to each program. So for user, it appears that multiple programs are getting executed simultaneously. However, that is not the case behind the scenes. So that's about multitasking. This you can observe on your normal machine whenever you just switch on your laptop or desktop. You see you open multiple applications together. You can work in Excel, you can work in MS Word, you can play music in background. Something is going on internet as a browser. So that way. Now let's come to our topic, which is multi-threading. And this is a fine-grained process in which we are saying a single program can perform many activities in parallel. Like very simple example we can take, if we everybody has worked on MS Word. So if you work on MS Word, then you see these operations are going on. User is typing on that document, that is checking grammatical mistakes in parallel, that is checking spelling mistakes in parallel. It is doing formatting for your document. It is auto saving document every 30 seconds or 1 minute. So MS Word is just one application and it is having multiple threads which are doing their activities in parallel. So conceptually, I believe this makes sense to everyone, and this is a very common example which everybody is using. Now let's come to Java. Java supports multi-threading as a core concept. That means you don't need additional libraries for that. We have this feature in Java itself where we can develop application which are having multiple threads and those can execute in parallel. So thread is, if we talk about what is a thread, so we can say thread is a single autonomous unit of a program which could be executed independently. Independently means if there are 5 threads running in an application, they are not dependent on each other. They can execute in parallel. And or we can say threading is a lightweight process. And if we talk about cost wise, it is expensive to have many processes, but we can have many lightweight threads. And we all know that JVM, Java Virtual Machine, executes the program. So threads are also controlled by JVM. Another very common example I can give you is like if you have seen we just go to the ATM and withdraw money. So there are a couple of operations happening. Something is coming on user screen, which user is providing some inputs in terms of the money or for saving account or current account, what it is, what type of account it is. Then it is storing something in database in the background as and when you withdraw money. It is sending SMS to your phone. That's one activity. It could send your email to your email account. So there are a couple of operations just behind the scenes which are working in parallel just for one banking withdrawal. So that could be another example. Now let's see how it is implemented in Java. So there are two concepts, two things, or two ways rather, by which we can implement threading in Java. One is extending class thread, and the other way is implementing interface named as runnable. So those are two ways to implement. So in this particular session, we'll try to implement the way one, that we can create a thread or some threads by extending class thread. Before that, let's focus on few more things like thread could be a thread can have many different states in its life cycle. So we can say a thread life cycle. A thread can be new where it is just created. It could be runnable. That means it could be executed, but right now it is not running. A thread can be in running state when it is in real execution. A thread is blocked when, say, it is waiting for some resource, like it has to write something to disk and it is waiting for the resources. Or it could be terminated when finally it stops. So in its life cycle, a thread can be in one of the following states. When we initially create, it is new, then it becomes runnable. Then as soon as we call start method, it start executing. It in its life cycle, it could be blocked due to some resources, say IO operations or some waiting for disk to write, or could be waiting for network connection, could be anything. And then finally it stops, it is terminated. So let's try to implement. Then we have to see some of the methods of thread class. So thread is a inbuilt class. And this class has the following methods. which could be used for implementation of threading. Start method is the command to get thread executed, or we are saying start executing it. Run is the method in which we write the actual functionality of the thread. And there are a couple of other methods, but let's discuss only for few important. Stop is to finally stop the execution. Now let's take some example. So let's do some hands-on and we'll see like how to get it done. So let me open. So I'm using this my code editor to save the program. Just creating a new file. Let's save in D drives. Let's create a new folder for this. Java execution. And inside that, let me create a file. Say thread implementation.java. Okay. So let me write some comments over there just to make it more elaborative, explanatory. So we are going to create one thread. We are going to create a class which extends thread. So from the implementation or from the concept of inheritance, we know that when dog inherits animal, dog is an animal. So in the same coordination, same analogy, we can say if class A extends thread, then class A is also a thread, and its objects are thread which can be executed. So we are just creating one class. Class A extends thread. So that simply means class A is also a thread. Now, as we said, whatever functionality we have to do with this thread, we'll write in run method, which looks like this. So let me simply We are running an infinite loop in which we are printing some hello message and the name of the thread, which we'll get from or let's see hello from thread A. Okay, this is a simple class, and to check how it works, we can say we can create this class thread implementation, and we can write public static void main string marks. This is a very common method which we know, and in this what we can do, we can create one object of class A. Let's name it thread1 equals to new A, and we'll simply say thread1.start. So this is simple implementation of a thread wherein every object of class A will be a thread, and we are simply creating an object and just starting it, and let's see what happens. Let's save this program. I'll go to the command prompt. I've saved where I have saved the program. I saved my program to D drives, Java execution. Here it is. Let's compile this program. Say Java C thread implementation.java. Public class thread is there is some spelling mistake or something wrong. Let's see. Thread implementation.java public class thread implementation seems correct. Let me figure out. Yeah, there's a spelling mistake there. It should be thread thr. Okay, I saved it again. Let's go back. Let's compile this one. And to execute, you write Java thread implementation. So we have run an infinite loop in which the thread is executing. So see this method. It is executing. It started executing. Okay. And if we want to see how multiple threads execute in parallel, we can just create one more class. You see class B extends thread, and this is message from thread A, and this is message from thread B. Now, similarly like this, we can create object of class B thread 2, and we can start thread 2 as well. Now, by execution of this program, we'll see 2 threads will be running in parallel. Let's save this back. We'll go back to our prompt. We'll compile the program again. And we can execute this. Now you see thread A is also executing, B is also executing in parallel. So this is how your multi-threading works. That is way number 1 we have implemented. And for reference, we can copy this program in our notepad. So I think we can end it up here today. And let's see how the implementation goes with the second phase, that is implementation of runnable interface. I think we can stop recording here.